Hello and welcome back to the channel. It's been a while since I released a video, but in today's video, what we are going to do is dive into the actual design and implementation of our game Battleship. So having said that, let's go ahead and switch over to Unity Editor and jump right into it. I'm going to go ahead and share my screen now. All right, so here we have Unity Editor. For this particular project, we decided to go with the latest Unity 6, LTS 26 F1. And what we want to do is start applying some of the concepts that we discussed in the introductory video. And if you haven't seen that, or if you don't know what a Battleship game is about, or if you want to get a perspective on the actual historical aspects and also the gameplay, go ahead and check that video. It's a short introductory video, and also it will kind of give you an idea of what we are going to be doing over the course of the next few videos coming up. So Unity 6, latest Unity, and apparently it's supposed to be the greatest. There are some really cool enhancements to it, and obviously there are some changes, so you might have to take some time to familiarize yourself with the actual new IDE and the graphical interface. But let's go ahead and just jump into it. So the primary task for us right now is to be able to implement the boards, the board layout. And if you recall, in the Battleship, it's a board game. So we are going to have two separate boards. One of them is going to represent the player's board, and the other one's going to represent the opponent's board. In this case, the opponent is going to be the AI. So what we want to do is first compose or construct the board units. And in order for us to do that, we are going to utilize Unity's built-in primitive system, geometric primitive. So we are going to utilize a cube. And let's go ahead and we are going to change some of the scaling over here. So we'll keep it at the unit scale. So X and the Z axis are going to be 1 unit, but let's go ahead and shrink it down to 0.01 on the Y axis. So that will give us a really nice kind of like a board unit, not too thick, not too thin. It's going to be pretty cool. So the next thing what we want to do is actually create a prefab of this, because later on we are going to utilize the prefab to dynamically generate the board. So in order for us to do that, we need to instantiate this particular game object at runtime. So there's several ways you can do this actually. You can actually do it all through code. You can create generate the whatchamacallit, a primitive at runtime, and then you can apply the scale similarly at runtime. So in this case, it's kind of pretty straightforward. So if you go that route, it's going to be super simple, not too many complex coding that you have to do. But generally speaking, it's best to once you have your model kind of set, you want to save that as a prefab, and it would be easier to instantiate that prefab. And then obviously the prefab itself is going to have a bunch of mono behaviors later on that you might want to incorporate. So if you don't, so one of the benefits of a prefab is to basically encapsulate all of those things in a particular unit. And when you're instantiating that unit, then pretty much everything that you have rigged up on that particular prefab is going to be available to you at runtime, and everything will work pretty cool. So how do we create a prefab? So the way I like to structure my projects is that I would have a proper folder structure for it. Obviously, you'd have a folder for models, folder for prefab, scenes, scripts, textures, audio, whatever it is, any asset that you have, you should have some sort of a structure to it, right? So in this particular case, in the prefabs folder, I already have created a board unit, and we can actually see that it's the same. So how do we do this? Simply you drag and drop that particular game object that's active in the scene over to your assets folder, anywhere in the assets folder. That would create a prefab for you. So once you create a prefab, what you can do is rename it. So I went ahead and renamed it to board unit. And it seems like now Unity doesn't allow you to create the same name as the other one. So basically, I'm going to go ahead and delete the old one. And let's go ahead and rename this board unit. There we go. So now we have our prefab. Let's just double check and make sure the transform information is all good. It's all good. Okay, cool. So the next step would be, okay, we need to somehow auto-generate this at runtime. In order for us to do that, we need to write some code. So we would create like a board manager. In fact, I've already done a board manager, but how do you create a script? Well, we discussed how you can create scripts in other videos. You can go ahead and take a look at them. But quickly, you go to create and notice over here uh, that the context menu has changed from the older versions of Unity, which is kind of good because now we have each category uh, on its own subfolder, basically, which makes it really nice eventually. Previously, if you were coming back from older versions of Unity, you would get an extremely long context menu, which you had to scroll up and down to find the specific components or objects that you were interested in. In this particular case, we go to the scripting and notice that even on the scripting side, we have a better context menu. So traditionally, majority of the scripts used to be mono behaviors. Now we have scriptable objects, which is cool. Then you can have just like an empty C# script, perfect for containers, data classes, and etc. Not scriptable objects, right? Just traditional classes without any behaviors. And then we have this new concept called playables. We'll get into this later, probably not in this particular series, but at some point after we complete this particular project, I'm going to talk about playables and playable behaviors. This is something new. We didn't have this before. So we'll take a look at this and see how we can take advantage of that. Then, of course, we have assembly definitions and references. So these are something new to Unity 6 as far as being able to directly create them from the context menu. So that's a good enhancement. So let's go ahead and create a mono behavior. So you just create a mono behavior and you go ahead and say board manager. Let's call it V1. I'm going to delete this. It's just for an example. And when you go ahead and create the script, Unity will do what it does. And if you double click on it, your favorite, oops, we zoomed in too much. Actually, that was by an accident. Let's set this back to 150 over here. Okay, so Unity will bring this up for you, an outline of your class. And usually I like to format the document for my tapping and etc. Now you have a base to get started. So in the class over here, this is what we are going to discuss, how to put this together to generate the board dynamically. So I'm going to go ahead and close this, switch over to the actual board manager that is implemented. And the reason I'm doing it this way is because it's going to take less time for me to, rather than type it up and then explain as we are going through it, I already have completed the script that we need to discuss, and all we are going to do is concentrate on the explanation of it. So in this particular case, we are going to generate two boards. One of them is going to be for the player, and the second one is going to be for the AI. And eventually, what we are going to do later on is that we are going to create separate classes that is going to handle each one of these board types. So just for the sake of it at this point, I just want to illustrate how you can dynamically generate this board and what happens. So let's go ahead and run our example. And we should delete that as well. We don't need it anymore. So in order for this to actually execute, it needs to be attached to a game object that's already inside the scene. So let's go ahead and create a board manager. So we create an empty game object called board manager. And I usually like to start all of the manager classes with an underscore and move them to the top. That way it's easier access. And what we'll do is drag and drop that board manager class over to the board manager game object as an attachment. And over here, we have two properties that are exposed. One of them is for the board unit prefab that we created. So let's go ahead and assign that. So just drag and drop that guy over here. And the other one is a parent transform. And this transform is going to be used as the origin where the center of the board is going to be. And then basically it's going to utilize that particular position to generate the two boards. So the player's board is going to be generated on the left side, and the enemy's board is going to be generated on the right side. So all we need to do is also allocate a transform. So we can utilize either the origin, which is placed at 0, 0, 0, or similarly the board manager, which is placed at 0, 0, 0. So let's go ahead and just utilize board manager. And now we have all of the inputs that the board manager is requiring. So now that we have those, let's go ahead and click play. And voila. So we have our board generated. So we have two boards basically. And right now you can't really tell about the board units, but there are board units here, right? So basically, if we open this up under board manager, we have board one, unit one, and it will go all the way down until it generates the 10 by 10 grid. And then eventually what we are going to do is start generating the first unit of the second board. And similarly, we do that. Okay, so pretty cool, pretty straightforward. And obviously later on, what we'll do is also learn how to extend this board unit to apply some materials to it and some world space canvases so we can identify the actual board with unique numbers and etc. But before doing that, let's go ahead and see how the board manager actually executed this code. So let's bring this up. So we have the parent transform. We have the board unit prefab object that we are utilizing to generate the board itself. Then we have some sort of a data structure. In this case, again, a two-dimensional board array of game objects of size 10 by 10. And what we are doing over here is that we are going to create a player's board. And when we are creating the player's board, we have two loops, right? The first loop is going to be for the rows, and the second loop is going to be for the columns. And basically, this iterates over it. Inside the iteration, we are instantiating our board unit prefab, but we are positioning it based on the units, in this case, the indices that are coming from the row and the column. And what we are doing is that we are attaching it to some sort of a parent object. In this case, the parent happens to be the transform that we have associated to the game manager. The next thing what we are doing is that we are applying some sort of a name using the string formatter. So we have B1, and we are passing in the row and the column, and we are formatting it to the C# numeric string, in this case, utilizing it with 2 digits. And eventually, what we are doing is that we are storing that game object that we just instantiated into our board array at that particular space, because later on we are going to utilize this to determine whether that particular space is going to be occupied or not. And then obviously over here, we are updating the name and incrementing our rows and our columns. So this is the pretty much the logic for it, right?
And
So we have
similarly,
the board, the creating AI board is kind of the same. So same mechanism, but we are starting our columns and rows. We are basically displacing them by X amount. And if you notice, our actual board unit itself was 1 by 1, which makes it super easy, right? So we are all incrementing by 1 unit. So in this case, we are displacing it at 11, wherever that 11 meters is. And from there, we go from 11 to 21 and so forth. So that generates and gives us the proper layout for this particular dimensions. All right, so that's it. This is how you would auto-generate the actual board. And one thing that we should also do is the following. Let's go ahead and select the camera and let's align it with the view. So that way we can actually see this particular generated board. And let's go ahead and copy the component of the camera, because if we turn the runtime off, it will be reset to its original position. Let's go ahead and now paste those values back into the transform of the camera. And if we run it again, it's going to give us the proper perspective for it. Very cool. All right, so that's it for this video. I'm trying to keep this video short because they do take quite a bit of time, but hopefully this was a good starter. In the next video, what we'll do is start enhancing the board unit and be able to actually identify it visually. And then we'll also apply some interactive abilities to it. Very cool. So let me go ahead and stop sharing this. All right. So thank you for stopping by and see you guys soon. Have fun. Don't forget to like and subscribe.